Okay, so today's chapter is root locus techniques. So this is part of our control system series. So the question is, the forward path open loop transfer function of a unity feedback system is given. Okay, so this is the unity feedback system they have given. Yeah. So we are asked to draw the root locus for this. Okay. So the idea is, so I have listed down all the rules which are required to draw root locus. I'll go over them when we need those rules. Okay. So there are 8 such rules. You may not need all the 8 rules for a given problem. And sometimes when you're solving MCQ, you can use process of elimination also. So to do it quickly. But anyway, I'll be solving it thoroughly, so that even if the MCQs are confusing or if you are solving objective problems, you can solve it. Okay, so we are asked to find the root locus of this transfer function. So basically when you say drawing the root locus, it means that this parameter k, right, the gain parameter, if we change it from 0 to infinity, okay, how does the poles and the zeros move? Okay, so when we move it from k is equal to 0 to infinity, right? So we don't need to go into theory of this. If you remember these rules, we will be able to draw the root locus. Okay, so first we need to find the zeros of the system. So zeros will be when the numerator becomes 0. So numerator will become when s is equal to -2 or s is equal to -6. Okay, and what are the poles of the system? Poles of the system when the denominator becomes 0. So when will the denominator become 0? So we have to solve this quadratic equation. Let's solve it. Okay, so -4 plus minus j3. So -4 is here, somewhere here, right? So these two are the poles, right? So when k goes from 0 to infinity, you traverse from open loop pole to open loop 0. So let's go to the rule 2. As k increases from 0 to infinity, we go from open loop pole to open loop 0. Okay, so in this case there are 2 poles and 2 zeros, so these are matched. Let's say if the zeros are lesser in number, then there will be no match for few poles, right? So those poles goes towards the infinity. So this rule is not yet applied here because we have equal number of poles and zeros. We will see in other problem, right, when to apply this. And root locus is symmetric about real axis. So if you draw for the upper half, lower half is just the symmetric of that, with real axis being the mirror. Okay, so now let's see. So these are my zeros and these are my poles. Let's go to rule number 3. Rule number 3 tells that a point in the real axis belongs to the root locus if the right hand towards that point contains odd number of poles. For example, odd number of poles are 0. So for example here 3 poles and 2 zeros are there, right? So 5 odd. So this point points in the real axis just before this one will belong to the root locus, right? So here if I see, so we have 1 0 here, no poles and nothing. So basically you can consider zeros and pole combined, so it's odd. So this line will be in the root locus. Okay, till here. Now once you cross this point -4, again there is 2 poles added, so again it's odd. So this line will also be in the root locus. So first part is done. And we know that the root locus starts from k is equal to 0 when it's at the pole and ends towards the 0. So the arrow would be like this. So it's ending towards the 0 and it will be starting from the poles. So it will be starting somewhere from here. I don't know how it will join this, because ultimately it has to join here for continuity. Whether it's joining like this or it's joining like this, I don't know. Okay. Now, if it's a MCQ, you will know because the options are right there. Okay. So you can mark the answer if the options are not confusing. But let's solve it properly, right? Okay, so we know that the root locus will start from here and end towards this, right? So let's try to find out what is the angle of departure from here. If the angle of departure, how to find the angle of departure? This rule 7 will tell you the angle of departure. So for poles and zeros both. So we are interested in the pole here. So it's odd multiple of 180 plus net contribution of angle from other poles and zeros. Okay. So let's first solve for this phi net. Phi net means the summation of angle contributed by other poles and zeros. So the pole in question is this. Right? So what's the angle contributed by other zeros and poles? So let's say this guy is contributing theta, right? We can solve for this because we know this dimension, but we don't need to, because this theta will get cancelled out by 180 minus theta, right? And what's the angle contribution here? 90 degree. So what's a phi net? Phi net is contribution from all the zeros, which is theta plus 180 minus theta is 180. Okay. Minus contribution from this pole, other poles. So only one pole, other pole is there, which is 90 degree. So we have 90 degree phi net. So what will be the phi p? It will be odd multiple of 180 plus this. So we can just take 180 plus 90 degree, which is 270. So the angle of departure we know is 270 degree. So let's remove this. Okay. So where is 270 degree? 270, like this is 0, 90, 180, 270. So it will be going like this. Okay. So we know. And what will be from here? Just the symmetric, right? Rule 1. So if it's going like this, this will be going like this. And joining the and reaching the 0. So from pole to 0. So this will be the root locus diagram. Okay. So we used rule 1. Okay, symmetricity. This will be almost every time used. We used rule 2 kind of, at least this one. Or rule 3 we used, right? And rule 7 we used, right? This one. Okay, let's try to cover all the rules using problems. Any other rules we use? No. Okay, so we'll solve another problem which might use few of these rules which we have not used yet.